Hey everybody, this is group B39 and we'll be introducing the Binomial Theorem. I'm Michael Denemy.
I'm Pauline.
I'm Juliana.
And I'm Zach.
Okay.
If you're interested in more information on discrete mathematics, then feel free to visit www.knotum.com. Thank you. The binomial theorem gives coefficients of the expansion of powers of binomial expressions. First, a binomial expression is simply the sum of two terms. For example, x plus y. Note that the expansion of the quantity x plus y cubed can be found through combinations. When x plus y cubed is equal to x plus y times x plus y times x plus y is expanded, products of a term in the first sum, a term in the second sum, and a term in the third sum are added. These terms are in the forms x cubed, as x must be chosen in each of the sums, x squared y, x is chosen in 2/3 of the sums, so x must be chosen in 3 choose 2 ways, xy squared, pick one of the three to be x, and you have 3 choose 1 ways, and finally, y cubed. The only way to obtain y cubed term is to choose y for all three. Let us break this down to make it simpler to understand. The quantity x plus y cubed can obviously be broken down into x plus y times x plus y multiplied finally by x plus y. This equals xx plus xy plus xy plus finally yy. This is still multiplied by yet another x plus y. Now, sparing you us rewriting it, this multiplies out finally to xxx plus xxy plus xyx plus xyy. You get the picture. And finally, this simplifies to x cubed plus 3x squared y plus 3xy squared plus y cubed. This then leads us back to the binomial theorem. Let x and y be variables, and let n be a non-negative integer. Then we have the quantity x plus y to the n is equivalent to the sum from j equals 0 to n of n choose j times x to the n minus j times y to the j. Breaking this down as we gave in the previous example will give us n choose 0 times x to the n plus n choose 1 times x to the n minus 1y plus n choose 2 x to the n minus 2y squared plus dot plus n choose n minus 1 xy to the n minus 1 plus n choose n y to the n. Clearly. To provide the proof of everything we've gone over, the terms in the product, when it is expanded, are of the form x to the n minus j times y to the j for j equals 0, 1, 2, dot, n, to count the number of terms of the form x to the n minus j times y to the j. To count the number of terms of the form x to the n minus j times y to the j, note that to obtain such, it is necessary to choose n minus j x's from the n sums, so that the other j terms in the product are y's. Thus, the coefficient of x to the n minus j times y to the j is n choose n minus j, which the student money you will note is equivalent to n choose j. 3. Before we move on, I would like to remind you that if you would like to know more about this subject and other important discrete mathematic topics, you can visit www.knautum.com. Thank you. Now let's move on to the next example.
For our example, we'll be expanding a plus b to the power of 5, where n is equals to 5. For the next step, according to the definition, we'll have 5 choose 0, a to the power of 5, b to the power of 0, plus 5 choose 1, a to the power of 4, b to the power of 1, plus 5 choose 2, a to the power of 3, b to the power of 2, plus 5 choose 3, a to the power of 2 times b to the power of 3, plus 5 choose 4, a to the power of 1 times b to the power of 4, plus 5 choose 5, a to the power of 0 times b to the power of 5. So 5 choose 0 is equals to 5 factorial over 5 minus 0 factorial, 0 factorial equals to 5 factorial over 5 factorial, which is equals to 1. And this goes the same for 5 choose 1, which is equals to 5 factorial over 5 minus 1 factorial times 1 factorial, which is equals to 5 factorial over 4 factorial times 1 factorial, which is equals to 5. Okay. Then we can do the same thing for 5 choose 2, 5 choose 3, 5 choose 4, and eventually to 5 choose 5, which is equals to 5 factorial over 5 minus 5 factorial times 5 factorial, which is equals to 1. And eventually, the whole thing will be equated to 1 times a to the power of 5 times b to the power of 0 plus 5 a to the power of 4 b to the power of 1 plus 10 a to the power of 3 times b to the power of 2 plus 10 a to the power of 2 times b to the power of 3 plus 5 a to the power of 1 times b to the power of 4 plus 1 a to the power of 0 times b to the power of 5. And this will equals to a to the power of 5 plus 5 a to the power of 4 b plus 10 a to the power of 3 b squared plus 10 a squared b to the power of 3 plus 5 a to the power of 1 b to the power of 4 plus b to the power of 5.
Thank you for viewing our video regarding the binomial theorem. This has been Group B39 with Michael Denemy, Pauline Lowe, Zachariah Girth, and Juliana Mee. If you would like to view more videos regarding the binomial theorem and other difficult topics on discrete mathematics, please visit http://www.it's noatom.com. Because this is atomic knowledge and no, yeah. Oh.